Imagine looking up at the night sky and discovering a planet that seems to ignore one of astronomy's oldest rules. For centuries, scientists believed planets form inside flat, spinning disks of gas and dust surrounding young stars. That means planets should orbit roughly around their star's equator, just as every major planet in our own solar system does around the Sun. But then astronomers found something astonishing. A distant world wasn't circling around its star's middle. Instead, it was traveling almost directly above the star's north and south poles. It was as if Earth suddenly decided to orbit over the Sun's poles instead of around its equator. At first glance, it seemed impossible. Yet after years of careful observations, NASA and international astronomers confirmed that this bizarre planetary system is real, and it may completely change our understanding of how planetary systems evolve. This is the story of one of the strangest planetary orbits ever discovered. To understand why this discovery shocked astronomers, we first need to understand how planets are expected to form. A star begins life inside an enormous cloud of gas and dust. As gravity pulls material inward, the cloud starts spinning faster, flattening into a giant disk. Inside that spinning disk, tiny dust grains collide. They grow into rocks. The rocks become planetesimals. Eventually, entire planets emerge. Since everything forms inside the same rotating disk, nearly every planet should orbit along the same general plane. Our own solar system is a perfect example. Mercury, Venus, Earth, Mars, even the giant planets all travel in nearly the same flat plane around the Sun. For decades, astronomers believed this was simply how nature worked. Then, powerful space telescopes began revealing something unexpected. Some exoplanets weren't following the rules. A few traveled on highly tilted paths. Others even appeared to orbit backward relative to their star's rotation. Each new discovery hinted that planetary systems could be far more chaotic than anyone imagined. But one system would push that idea to the extreme. The planet is called 2M1510AB-b. It orbits an unusual pair of young brown dwarfs, objects larger than planets, but too small to sustain normal hydrogen fusion like true stars. Instead of orbiting around their equator, this planet circles almost directly perpendicular to the orbital plane of the central objects. Imagine watching two spinning tops rotating side by side. Now imagine a third object circling over the tops instead of around their sides. That is essentially what astronomers observed. The orbit is called a polar orbit because the planet travels above the poles of the central objects rather than around their equator. Nothing like this had ever been clearly confirmed around such a system before. Naturally, scientists were skeptical. Could the data be wrong? Was another unseen object affecting the measurements? Or had astronomers discovered an entirely new type of planetary architecture? To answer those questions, researchers spent years collecting additional observations using some of the world's most advanced telescopes. Every new measurement pointed toward the same conclusion. The orbit wasn't an illusion. The planet truly follows a nearly 90-degree path relative to the brown dwarf pair. And that raised an even bigger mystery. How could a planet possibly end up there? If planets normally form inside flat disks, something extraordinary must have happened after this world was born. Or perhaps the disk itself evolved in ways astronomers had never fully understood. Either possibility challenges long-standing theories of planetary formation. For scientists, this wasn't simply another strange exoplanet. It was evidence that the universe may be building planetary systems in ways that textbooks never predicted. And as researchers looked deeper into this remarkable system, they uncovered clues suggesting that the planet's unusual orbit may actually reveal a hidden chapter in how worlds are born. If this planet truly travels in a polar orbit, then one question becomes impossible to ignore. How did it get there? Astronomers believe there are two leading possibilities, and both paint a picture of a much more dynamic universe than we once imagined. The first idea is that the planet formed in a disk that was already tilted. Around a pair of closely orbiting brown dwarfs, gravity is far more complicated than around a single star. Instead of remaining perfectly flat, the surrounding disk of gas and dust may gradually twist over millions of years. Computer simulations have shown that under the right conditions, the disk itself can slowly tip until it becomes almost perpendicular to the central pair. If planets form after that happens, they would naturally inherit the disk's unusual orientation. In other words, this world may have been born sideways. The second possibility is even more dramatic. Perhaps the planet originally formed in a normal orbit, but later experienced powerful gravitational interactions. A close encounter with another massive object, or the long-term pull of the binary system itself could have gradually tilted its orbit over millions of years. Neither explanation is fully proven yet, but both suggest that planetary systems are far more flexible than scientists once believed. For decades, our solar system shaped the way astronomers imagined every other system. Now, discoveries like this are reminding researchers that our neighborhood may be just one example among countless possibilities. Finding this extraordinary orbit wasn't easy. The planet is incredibly distant, making direct images almost impossible. Instead, astronomers relied on extremely precise measurements of the motion of the two central brown dwarfs. As the unseen planet orbited them, its gravity caused subtle changes in their movement. Those tiny shifts acted like invisible fingerprints, allowing scientists to reconstruct the planet's orbit through careful analysis. This kind of work requires years of observations and extraordinary precision. A single measurement isn't enough. Researchers must repeatedly observe the system, compare data, eliminate alternative explanations, and test whether every observation fits the same model. In this case, the evidence continued pointing toward the same remarkable conclusion. The orbit was real, and because independent analyses agreed with the measurements, confidence in the discovery grew significantly. This discovery is important for another reason. Astronomers have now found thousands of exoplanets. Some are larger than Jupiter, some orbit 2 stars, some are scorched by extreme heat, while others drift alone through interstellar space. Each new discovery expands our understanding of what nature is capable of creating. But a confirmed polar orbit planet around a pair of brown dwarfs fills a new category. It shows that planetary architecture can be much more diverse than the neat, orderly picture suggested by our own solar system. Every unusual system forces scientists to improve their models. Questions that once seemed settled suddenly become open again. How common are tilted disks? Can entire planetary systems evolve into polar configurations? Are there smaller, Earth-sized planets following similar paths that we simply haven't detected yet? Future observatories will provide those answers. Powerful telescopes, including NASA's upcoming missions and next-generation ground-based observatories, will be able to study distant planetary systems in greater detail than ever before. As technology improves, astronomers expect to discover many more worlds that challenge today's assumptions. Some may orbit at impossible angles. Others may rewrite entirely different chapters of planetary science. That is the true excitement of modern astronomy. Every discovery doesn't just answer a question, it creates 10 new ones. The universe continues to surprise us, not because the laws of physics are broken, but because nature is more creative than our imagination. A planet orbiting above the poles of its central stars once sounded impossible. Today, it is part of the growing evidence that the cosmos is filled with extraordinary worlds waiting to be discovered. And somewhere, in the vast darkness between the stars, the next impossible planet may already be waiting for us to find it.